Hello. Some of you might be aware by now that I tend to work on very small things. So you might be slightly surprised to find that lying around my house there are things like this. One of the absolute perks of working in paleontology is some of the places you get to visit. So I've been very fortunate in, thanks to Peter Van Rooij, being invited out to go to Morocco a few times. So I've worked there, back since 2002 I've been there the first time. And it's an extraordinary place, not just culturally and landscape, but in terms of the fossils as well. So we were there mainly to look at the Conservat Lagerstätten that you have in the Ordovician of Morocco. These are sites of exceptional preservation, most famously the Fezouata Biota in the early Ordovician, but also in the late Ordovician there is a deposit known as the Tafilalt Biota. This is spread over quite a few sites and is famous particularly for echinoderms, things like starfish, like that sort of thing, and their relatives like eocrinoids. These are all very well-known fossils now from this area, and they've been quite extensively studied. Most of them have been named. I've done the crinoids from there, and yeah, it's an extraordinary fauna. But one of the first things that started to appear in these beds of the Tafilalt biota that really attracted attention worldwide were these strange discs. And these are now also fairly well known. They have a name. They even have a place in the history of life, we think, but it's not where people might expect it to be. When you see a fossil that's large and circular with radial lines going across it, an obvious assumption might be that you're dealing with a jellyfish, and this has been suggested. However, it ain't a jellyfish. You can see this fairly clearly even with this specimen. Just about. If I get the light right on it, you can just about make out that in the central part there is a spirally, going backwards, a spirally coiled structure which doesn't quite overlap itself. It's not very clearly preserved here, but in other specimens it's much clearer. Whatever that is, it's not something that jellyfish has. In fact, it looks like a gut, a digestive tract. Jellyfish don't have a gut as such, they just have a sort of a blind stomach in a blob in the centre. So this is something else. And to work out what, we're going to need slightly better preservation. And where else would you go other than the Burgess Shale or Chengjiang? The Burgess Shale fossil Eldonia ludwigi has been a mystery since it was first described in about 1911. It's been put into the sea cucumbers, the jellyfish, siphonophores. It's been thrown around all over the place. But one thing it does show is that this does clearly seem to be a gut. To really understand it, though, we need to go to China. The Chengjiang biota has, of course, produced huge numbers of very important fossils, and it has relatives of Eldonia. This is a thing called rotodiscus, which also has been a problem for quite a long time, but increasingly people have been finding more intact material which shows more and more soft tissue detail. These specimens clearly show an array of tentacles around the mouth. Not only that, but they're quite distinctive looking. Unlike those of jellyfish, for example, they're unicerally branching. They have a series of branches coming off from one side. These structures are too soft to be preserved in the Tafilalt biota of Morocco, so what we're seeing here is much tougher. The details of the tentacles would have already rotted away, but there was something a bit tougher about this cuticular structure over the rest of the body. So we're starting to get at least a picture of what this animal looked like. And that's a very good start. But this paper by Liu Jing et al. That I've been showing you images from also has one more little trump card up its sleeve. A tiny little structure which is quite distinctive looking. This structure here is found next to the base of the tentacles, and on the left what you can see is an almost identical structure for the modern tunicates, sea squirts. Now, in sea squirts, it covers the opening to a coelomic system, and in the Chengjiang specimens, it appears that the preservation of the tentacles is consistent with them being hollow, so also coelomic. And therefore, it looks like it might be the same structure, a cover for a pore leading into the hollow part of these tentacles. A finding like that also is very helpful for potentially confirming another similarity, in that this tentacle structure is quite similar to a strange creature called Herpetogaster. This has recently been interpreted as a relative of echinoderms and hemichordates, what we call the ambulacrarians. This is all getting quite obscure terminology, I know, for some people, but this is basically relatively close relatives of us. Animals with bilateral symmetry can be divided essentially into two major groups, the protostomes and deuterostomes, and the distinction goes back to embryology. It's a fairly fundamental distinction. The deuterostomes are a small group of just a few phyla, which includes the vertebrates, the chordates, i.e. us, and also echinoderms, hemichordates, which are a group that include graptolites, for those who are used to finding them, and things like acorn worms today, and also the sea squirts, the tunicates. Despite first appearances, the echinoderms and hemichordates are actually sister groups, in that they are the most closely related groups to each other, and they together are called the ambulacraria. Despite the difficulty seeing links between these groups, if you look at the individual animals, the zooids within a graptolite, or their relatives today, the cephalodiscids and raptopleurans, then you can start to see the close similarity with things like Herpetogaster. So the interpretation that is now fairly well established and reasonably well accepted is that these paropsonemids are an offshoot of the stem group of the ambulacraria. In other words, they're in this pink area on the diagram at the top there, where you have ancestors to both the echinoderms and hemichordates, which looked a bit like Herpetogaster, and then they evolved down this slightly odd route of having a huge disc-like body which was quite toughened, but still retaining the same tentacles and the arrangement of the gut. So at the end of all that, we're left with a situation where there's now reasonable certainty that this great lumping thing here is actually quite closely related to this thing here. Who'd have thought it? I think that's probably going to do for now. It's one of these stories that I'm sure there is more to tell, there is a lot more to discover, because it's such a weird offshoot of the evolution of deuterostomes. And at first glance, you would not see that and think, it's clearly a close relative of hemichordates. It's only when we're starting to piece together all of these different bits of evidence from exceptionally preserved faunas around the world that we start to get enough information to start to pull it all together. And it still leaves unanswered questions. So for me, one of the big ones is, that's quite a small little tentacle array. How is it feeding? How is it getting enough food to support such a big body? Because that's a chunky thing. We don't know quite what it was made of. We don't know how the space inside it was filled. We don't know why it had such a big body. The gut is a relatively small part of it. What else was there? There's an awful lot we don't understand about these things, including how they lived. They also turn up in odd places around the world at different times. They go from the Cambrian up to the Devonian. So they're quite widespread. But most of the time we don't see them. They're a gap in the fossil record. A lot of the fossil record is gaps. This is why it's so exciting when you get anywhere at all where you do get the soft tissue, and why paleontologists just carry on looking for more of it, because you never know what's going to turn up next. So, yeah, keep your eyes open and you never know what you'll discover. And on that note, I shall leave you till next time. Fare thee well. I wonder if this works as a frisbee.